Blockchain and smart contracts go hand in hand. It's the foundation of crypto, DeFi, GameFi, and even the Web3 metaverse. But guess what? Even today, smart contracts still have many limitations for the real world. PraSaga brings a unique solution instead of smart contracts, but with a blockchain OS and dynamic smart assets. Today, we're speaking with Michael Holdmann, founder and CEO of PraSaga. Let's find out more in today's episode. Michael, how are you doing today?
Oh, fantastic. Thank you very much. It's great to be here.
Likewise, yeah. We're very happy to have you on the show and really talk about, PraSaga and the vision behind it. So to start off, right, in the most simplest terms, can you tell us what is PraSaga and what is it that you're solving? What are the challenges?
Absolutely. And thank you for asking that question first, so we can kind of lay that out for everybody. Elon Musk would coined as a single layer blockchain, something that he mentioned in the B Word podcast that he did with, I think it was Catherine over at ARC and Jack Dorsey.
Yeah.
And basically what he was looking for is where there are no layer 2s or layer 3s or layer 0s, it's a single layer, and then the de facto layer 2s are just the exchanges, and which is how you get on board and off board into the blockchain economy. And that's what we have built or are in the process of finalizing the build of right now. We came into this in September of 2017. The reason that we came in was not to build a blockchain. That was the furthest from our mind at the time. We came into this to actually integrate a blockchain into a high-performance Internet of Things and smart city message bus. The problem is that although blockchains are good, or the current Gen 1 are good, they do what they say they do. They move a smart contract, or they move a wallet address from one smart contract to another. The problem is, and we're finding this evident in, like, for instance, IBM getting out of the blockchain industry because they couldn't do anything complex with smart contracts. They could only do simple track and trace. Here, QR code, scan it, it's here now. Oh yeah, this tuna is now here. Oh, now it's here at this processor. Oh, now it's moving here to the freight company, whatever it is, right? But they couldn't really go in and it's composability, but it's basically just tying all of those contracts, those smart contracts together. You can't get into complex process. So that's what we built and solved for.
Understood. Okay. So that's like, I've heard these similar narratives too, because smart contracts, simple things like transfer tokens, yeah, it works, right? But today, increasingly, lots of applications and use cases are becoming a lot more complex. And we're starting to face these problems where it's just too brittle, it just doesn't work anymore. So can you maybe kind of give an example, from the real world or even in industry, right? How exactly, right, this problem is being portrayed?
Yeah, so a simple one, I guess, would be automotive supply chain. Let's just start there, right? So an individual car has over 1 million parts to it. So in a smart contract world, each one of those parts is a separate smart contract. And each certificate that is that proves that that part is or meets the spec, meets the, is compliant with, like, say, the meteorological composition of the bolt that's in the motor mount on the car, right? It's got to be a certain strength and such. Yeah. So the certificate proving that meets his part is also another separate smart contract for every single part that has a certificate. And then you have the accounts of all of the manufacturers, the suppliers, the consultants, and everything. That's also another smart contract. That is the biggest issue. It's just impossible to connect all of those together. There's millions of smart contracts in just a single car. How we solve this, or what we've done is, this is myself and my CTO. We've both been in the tech industry now for 6 decades. We both started in 1978. Me installing phone systems and David writing code when he was 14. And that's David Bieberman, my co-founder and CTO. My co-founder and CMO, Jay Moore, He's actually been in focused mainly on video gaming, and he's been in 5 decades working now. I think his first endeavor was '84 that he got into. So, and he's been mainly video gaming. Jay was he coined the phrase indie dev and indie gamer. So we've got a lot of experience within here. And what we did is reached back to, this is the 21st startup now between the 3 co-founders. We've had 8 exits, over 100 million in value on those. Well, what that architecture was, it's just called a message passing architecture. And it's the significance is it's the same underlying foundational architecture, although modified somewhat, as used in Windows, Mac OS 10, Linux, and any other Windows-based operating system, regardless of the device, whether it's a laptop, a tablet, a phone, a PC, it doesn't matter. A Windows-based operating system has that same capability, that first-class object model or message passing architecture. What we've done is implemented that first-class object model, that single instance global class tree, onto the blockchain. And this is a really significant change in not only a blockchain, but actually how the world will compute for the next millennium, if not further beyond.
I mean, look, with 6 decades worth of tech experience, 21 successful exits, I know this is a serious deal, right? So what are other problems with smart contracts?
So in the smart contract world, what you do is you basically copy another smart contract, paste it into your editor, change it, and then upload all of the same code that you just downloaded or just pulled down from the blockchain.
Yeah.
So you just keep duplicating this, and depending on how big the smart contract is, it's a lot of data, right? And you keep putting this up there and putting this up there. Well, there's 2 issues with that. First of all, that you keep repeating the same data that you don't need to, right? And instead of, it's kind of like writing the Word application every time you want to write a Word document, right? It doesn't make sense. So the second thing is, if there is a bug in that smart contract that you copied and you pasted that and put it up, there's no way for that smart contract to tell you, hey, I just discovered a bug, you better go in and change and fix your smart contract.
Yeah, true.
Where it just keeps, and then if there's 10,000 instances where that smart contract was copied, there's 10,000 instances of that bug that nobody will ever be alerted to until basically it happens to them, right? Until the bug affects them. So that's how a smart contract works. The other problem with smart contract is it is serialized. I cannot move a smart contract from one shard to another shard on a blockchain. So that means that all accounts have to be on the same shard. And that means that that smart contract is then serialized to that shard, and the entire blockchain will only go as fast as the slowest shard. It's difficult because it's serialized. Each smart contract only goes one at a time. We compare this to what used to be the operating system of the world, MS-DOS. MS-DOS was Microsoft's operating system before Windows, and it was a command line based operating system. It ran one program at a time, just like a smart contract. It is MS-DOS. You can run one smart contract at a time. You cannot do parallel. Even on layer 2, although it's technically feasible to use layer 2, it's still very inefficient and very insecure. You don't know if you're dealing with a fork of the shard on the other side when you're trying to move this contract from one to another. That's just one instance of an issue that's in it.
True.
So what we did, and what a class tree is, and this is where the explanation will fit in really well, on every single individual device in the world, a laptop, a PC, a tablet, a phone, that operating system has what's known as a class tree. And the class tree is just a bunch of code that's already pre-written. So if you have an application, and your application that you're writing has a button in that application, well, then what you do, instead of writing the code for the button, there is something called class button in that class tree on that individual device. So you just reference class button, and that's the base code for what a button is. And then you're just changing the parameters. My button is blue.
Right.
It's round, and it does this when it's pushed.
Right.
Every single application on that PC or that device that has a button in it is referencing that same exact copy of code. So that code is running all of those applications. The applications to define what their button is. What we've never been able to do in industry is share those classes across devices.
Right.
Which was something that would be very beneficial. What we figured out to do is we figured out a way to go ahead and implement that class tree on the blockchain. So now we have a single instance global class tree. So instead of writing code now, you're referencing class stock, class fungible asset, class non-fungible asset, class part, class whatever, class account, to create another object of yours in your account. So all state moves from a smart contract, which are eliminated, into your account. The reason that we can scale is because I can move accounts from shard to shard. So we found a way to move state from shard to shard. Thus, our limiting factor, where we bottleneck, is the actual internet bandwidth. And that's what we've done to solve. So not only does it solve the problem of scale, it also solves a big problem of go-to-market. Because if I'm just referencing code and changing the parameters, it's 100x, 1000x faster to market with that, because I'm not having to write any applications. It gets us to something that's called trustless code. If I know that class part is running 400,000 times on this blockchain, I can trust that code works. Now, to the point where, what if there's a bug in that code gets introduced? There's a certification tool you'll go through, but that can only check structure. It can't check what you write within the fields, right? So, but if there is a bug, the fact that it's running on all of the instances, everybody will notice it immediately. Unlike in a smart contract, where you have a smart contract, you copied from one that has a bug. That one that has a bug doesn't know you copied it necessarily, and is not and isn't going to send you a message say, hey, you better check your smart contract. There's a bug in it. In this instance, everybody knows because it affects everybody immediately. It gets fixed right away. And that's one of the biggest things with Linux.
Right.
Think of the Linux operating system, Linux Foundation, right? Everybody's using it. A bug comes, they jump on it immediately because it affects them all.
Right.
And they know that it affects them. So that's it. And I hope that gave you an idea between smart contracts, what their faults are, and how we fixed it.
No, absolutely. So it almost seems like we're taking the already established, best industry practices in programming, coding, how to launch software, and using the infrastructure, security of blockchain. Would that be correct?
Yeah, exactly. I mean, that's one thing that we've done, right? We've been, like I said, we've been in this a long time. Because of the protocol work we did when we were at NIST, the National Institute for Science and Technology, in the 80s, there is a Web 1. Yeah. TCP and IP, and we sat at NIST with Vince Cerf and Bob Kahn, who are TCP and IP. They wrote those on the line, but it's the protocols that sit above that allow those two protocols to actually become the World Wide Web. We wrote some of those protocols. We're directly responsible for Web 1. In the 90s, David Bieberman had a company. It was a joint venture with a gentleman called Ross Wheeler. And the company was Routerware. Routerware wrote over 50 high-performance IP protocols that are known as it's a high-performance IP stack. It was sold to Wind River in 1999. It's known as a Wind River IP stack. It was chosen by Juniper, Extreme, Foundry, and others over Cisco's IP stack. Because of the protocol work that we did in the 90s, we are directly responsible for Web 2. And we believe, and that's kind of what we did here, took all of the work that we did, Jay with his community building and such at Garage Games, It was the very first ever open gaming engine, built a community of 250,000 developers that were using their code in order to write their games, right? Um, all of the work that we did in the past, all of the protocol work that we did, all of the programming language work that we did, and we've written in 63 programming languages. Because with the modifications we did to Python, this could be considered the third programming language we wrote. We actually, the very good chance that a programming language we wrote in the early 90s or late 80s, early 90s called TCL was the impetus for Python, actually, because there's a lot of similarities between this embedded operating system, and embedded systems are basically manufacturing systems, control systems, production lines, and such. This embedded operating system, there's a lot of similarities, and Python came out after. We really have an understanding. We're taking all of that information and all of those innovations that we did over the past 4 decades and kind of making our swan song here, right? Put all that together. How does it work best together with everything and give that out to the world?
When it comes to the operating system, right? Like smart contracts, there's always this notion that, hey, you need to learn Solidity. There's a learning curve. What about PraSaga, right? What is this operating system?
Yeah, that's one of the biggest things, right? Is the actual programming language. We chose Python. Python is a first-class programming language. So it has that dynamic first class in there, but it's not a first class object model. We did have to do a little modification to it, excuse me. We call it Saga Python. And any Python developer will easily see what we've done. We actually have a organization out of Hanoi that has 600 developers called VMO. They went ahead and took had some of their Python devs review. We've got about a 2-hour video with David Bieberman doing a deep dive into exactly what changes he made on Python and how to write a class, how to write an object, which will basically be your stuff. And they dedicated some of their team to Saga Python. And they wrote a simple application just to show that, yes, they do understand the class object model and such, and said this was some of the easiest dev they've ever done. So that was a good thing there. We chose Python because there's an ocean full of Python developers in the world. There's a pond full of Solidity developers. We believe one of the reasons for slow adoption is because it's hard to pay a Solidity developer to write a proof of concept smart contract more than you pay your CEO a year. Right. Yeah. And in a lot of cases, that is what's happening now. So why not open this up and let's get adoption? I mean, we're here for 8 billion people in every entity in the world, right? We're here to be the underlying foundation of all transactions, all global transactions, financial or other, because a transaction is not just buying something or trading a coin. A transaction is also moving the part, the wiper blade from the supplier to the manufacturer between the accounts. Yeah. So we believe that that Python will make this a lot easier. And there's also, we've already written, although it's not implemented, multi-language implementers in there. So you'll actually be able to write a class in any object-oriented language. You'll be able to write your application in any object-oriented language with a garbage collector on all of them. But we don't care, and we'll have it so that it just translates over.
Yeah, I think Python is an excellent choice really for adoption because I've experienced it firsthand too. You know, I remember teaching a Python, right, to 10-year-olds. No coding experience at all, just, you know, normal smart kids. They learn how to code and even build like a simple 2-dimensional game. It's like Pong, right? And just within 1 week. Right. 1 week, right? Basic. So that's kind of like the power and speed of how, you know, Python can be adopted. So I think it's really great that you're taking this approach because it's not something that, you know, the other 1,000 other blockchains are doing.
I just don't see any projects out there focused on how do we get the rest of the world to adopt us, right? Yeah. How do we get the 96% of the population that's left to be, that's not involved? And that's really what we're trying to solve. And the reason that our focus is starting with enterprise And I always say this, nobody went to the banks in 99 and said, I want to do all my banking from my phone. Now, we
Yeah.
may hate our bank, but we trust them because we have our money there, right? Um, so what they did is they came to us with this application for online banking. Now, we were reluctant at first, but the adoption came. We did trust them. We said, okay, if you're saying that I can use this and it's going to be secure. And by the way, this is really easy. You say, put my name here, put the person name here, or the company name here that I'm sending to, and put the amount here and hit send. And boy, that's very easy. That's very convenient for me. That's where we believe the adoption of mass consumer adoption is going to come from the enterprise introducing a technology that the populace doesn't care that it's a blockchain.
True.
They don't want to know.
True.
Just like they didn't know that it was the internet, necessarily. They don't know how the internet works, the average person.
Yeah.
But they knew that they had this app here that was able to do something useful for them.
Yeah.
And that's really where we have to be at. We believe that the adoption will come through enterprise to the average consumer. Take a look. Anything you write now will run on the chain. It's all production level code. We are looking for contributors. We need developers to help contribute to this. It's now time for us to build that community.
Yeah.
Right. That's the biggest point here is how do we get that developer community? How do we find those core developers and such like that want to contribute and participate within the project?
Absolutely. And I think, one way to speed that up is really just show by example, right? What can be built. Earlier, you were referring to the automobile, right? The parts and like the provenance. I was also reading one of your, blogs and like videos talking about like the automobile recall issue and how PraSaga can potentially solve that. Yeah, can you explain more about this use case?
One of the biggest problems with recalls is that the longer it takes for a company to get the data to the government, the worse it is for the company, right? Yeah. Because they don't have everything in order in the eyes of the government. The problem is everything is still very manual at enterprise. You still get faxes of certificates.
Really?
Proving the meteorological composition of the bolt that's going into the motor mount, okay. Right? And it's so they have this in fax, so they have to manually put all this information together. What we solve there, because of the composability through everything, every single individual car that somebody owns, we know all full ancestry, where everything came from that's part of that makes up that car, all parts, all assemblies, all certificates proving, all vendors, that the suppliers all the way down to raw material. So if a recall comes, you have immediate, transparent, immutable access to that data to give to the government. So solving a problem of, first of all, if, one of the problem statements in the demo that we did for Bosch Engineering was they wanted to know if they received a part that didn't meet spec, that they would be alerted to it, so they would not put that part in the vehicle. In our world, if the certificate that's attached to that part does not match the spec that was put out in the request for proposal or the request for parts from the manufacturer, it wouldn't even show up in inventory list. So that's, so there's multiple steps that are automatically solved in recall situations. So you can at least be assured, it's not saying that there will never be a recall, but you can be assured that it will mitigate most of the issues that create a recall, because you can be assured that it is, unless for somehow the certificate authority is lying, you can be assured that yes, this is all the parts are proper, they should be here, they meet all the spec in order to be in here, and so on and so forth. So the industry is very, very excited about that.
Yeah.
That part of it on the compliance parts. Yeah.
Yeah. And then let's say, from the user's perspective, back to the car example. Okay, I have a car made up of thousands of individual parts. Each part is tracked, on PraSaga blockchain, right? And of course, cars need to be maintained, upgraded, repaired. Let's say I change my engine. Basically, the engine inside my smart asset changed, so I'm still able to track this as like one smart asset, but even the individual pieces inside.
Right, exactly, because that's an assembly, right? I mean,
Yeah.
you would have it's an assembly of multiple different parts that are in there. But if you change the engine out, it's still going to have the ledger object ID, that
Yeah.
256-bit string from each one of those parts
Mm-hmm.
referenced within that assembly, that whatever that assembly ledger object ID is. And when that goes into the vehicle, it's recorded on the blockchain that this is the new motor or engine that's in the vehicle. Right.
Right.
The old engine is no longer in that vehicle,
Mm-hmm.
and that old engine LOID can be. I don't know what exactly would happen to it. It's just saved. It's recorded,
Yeah.
so you always know it's there. But you don't necessarily need to keep the state of it anymore on the blockchain because it's no longer a valid unit. And we call it account containment tree.
Mm-hmm.
So your account, and that's the vehicle containment tree.
Mm-hmm.
Everything that's contained within that vehicle is within that object.
Got it. Now, I was actually reading about the collaboration with PraSaga, MetaHug, and Roblox. This is a bit of a fun take, and can you explain more about what this is and why PraSaga is doing this?
Yeah, absolutely. So education is our biggest thing, right? We are a
Yes.
foundation. We registered as a foundation in Switzerland on June 20th of this year of 2022. We're a nonprofit, and in order to build this out, we're working with a few different organizations, and we've got some more professional organizations coming to us asking us to participate for job creation and education. Right, so Roblox is a very good way to start to educate, and we'll be doing some Python Roblox training videos and such for anywhere up to 22 years old. I'm being told participate in Roblox. Right, it's not just grade schools or anything like that.
Yeah.
But it's actually goes up, and you can do some education videos in Roblox for college level.
Right.
So that's really what our focus is there. How do we educate the younger generation, bring them into into this world as creatively and matching their desired way of learning
Yeah.
the best.
Yeah. Yeah, I think that's true education, right? When you can find a resource, learn on your own, and really eventually give back to others. And that's that network
Right.
effect we want to see in the developer, Web3 community.
Right.
Yeah.
Right.
Brilliant. Okay. Yeah, I really can't wait for, all of the creative minds that are going to jump in and participate. Wow, that's a lot of good information. But yeah, to kind of wrap this up, is there anything you would want to share with the community?
Yeah, those that have been with us for the 5 years or known about us for the 5 years and kind of been positive about us, we really, really appreciate. It's been a long road in order to get to the point where we're at, but there was a lot of things here to fix. We are the team to fix them. I'm absolutely 100% confident in that because of the fact that we've created most of the things that were that enable this to happen in the first place. This whole blockchain industry. We are looking for developers. We are looking for projects, and we are looking for miners. We have we are involved right now in a validator block producer because we are POS POW in a block producer round pre-sale to be able to stake and be part of the test net. We're looking for 1,000 nodes to help us in public test net. To ensure that we got everything done before we launch mainnet.
All right, Michael, lots of great information. I really enjoyed this one because I think it's the first, blockchain that we interviewed that is not using smart contracts for very good reasons.
Right.
Yeah, so thank you for coming on the
Right.
show. We hope the best for your projects. We hope that your community will grow in meaningful ways. And yeah, let's catch up again in a few months, when there's more progress.
Yeah, absolutely. Please, and everybody join our Telegram channel at PraSaga Official. That's PRASAGA. PraSaga.com is our site. Twitter is PraSaga Official. YouTube is at PraSaga Official. Join the community. Let's change the world together, because that's what this project is to do, is change the world.
I like that. Together, right? Together.
Exactly.
All right. Yeah, thank you, Michael.
Thank you, Haku. I appreciate it.
All right, see you next time. Bye.
Guys, for the latest news and updates,
Be sure to follow our social media, including Twitter, Facebook, Telegram groups, and TikTok.
there you go. Follow us.
Links down below.